let's prove that the derivative of arctan of x is equal to 1 over 1 plus x squared. Let's say that y is equal to, our angle y is equal to arctan of x, where x here is our function, right? We can rewrite this as x is equal to tangent of y, right? Let's make this into a triangle. If I know that tangent is equal to the opposite over the adjacent, let's say this is my angle y, then my opposite would be x, and my adjacent side would be 1. And from the Pythagorean theorem, I can conclude that the hypotenuse would be the square root of 1 plus x squared. What else can I gather from this triangle? If this is my angle y, then I can collect information about sine and cosine. Our sine in this case is the opposite over the hypotenuse of the triangle, so that would be x over the square root of 1 plus x squared. And our cosine is the adjacent over the hypotenuse, which would be 1 over the square root of 1 plus x squared. We'll come back to this. Now with all of this information, we can start by actually proving and doing the derivative. So let me expand this out. X is equal to tan y. Let's differentiate both sides of this equation. Because I have two variables, because this is an implicit function, we're going to have to do implicit differentiation. On the left-hand side, the derivative of x with respect to x is just 1. And the right-hand side, the derivative of tangent y is going to be secant squared y, and remember to multiply by dy dx. Now we must isolate dy dx by just dividing secant squared y on both sides, and we know that secant is 1 over cosine, so I'm doing 1 over secant squared, that's equal to 1 over cosine squared, which is just cosine squared, right? Now remember how we collected information from our triangle here, that cosine y is equal to 1 over 1 the square root of 1 plus x squared? Well, let's just rewrite this here. I have 1 over the square root of 1 plus x squared, all squared, is equal to 1 over 1 plus x squared. And this is correct. And if you don't believe me, or if this is not proof enough, let's try to reason through it. If I were to draw the graph, or if we were to look at the graph of arctangent of x, we would notice that it is positive, its slope is always positive and it's always increasing. This makes sense with our derivative here, because if we put any value of x, our output is going to come out positive. Therefore, it would make sense that our slope is always going to be positive. And that way, we know that we have proved it correctly.